Hello, my name is Farzaan Siddiqui, and today I'm going to be explaining the simple yet effective design change of a modified soap dispenser. The automated soap dispenser was first introduced about 30 years ago. The design has undergone quite some change, but has primarily remained the same. The process of the system begins with a sensor that is used to detect some type of motion towards the dispenser. After receiving the signal, the system uses a motor to release a pre-measured amount of soap. This process removes the need of having to physically touch the product and helps maintain cleanliness. It has had a great effect on personal hygiene and minimizing product waste. The current design is suitable for consumer use, however, there are a few inherent problems with the dispenser. For better observation, let's look at a common design for an automated soap dispenser. We're going to be examining the Perel ES6 automatic soap dispenser. Here is a simplified version of the product drawn in 3D modeling software. Now, for simplicity, let's break this design down into 4 parts. Here we have an exploded view of the assembly to better display the individual parts. First, we have the soap refill. This part consists of the container holding the soap and the nozzle that controls the flow of the fluid. This part also houses the battery that powers the whole system. Next, we have the main body of the dispenser. This part holds all the components of the assembly together and is mounted into the wall. The motor that drives the system also resides within the body. Next, we have the nozzle clamp. This part wraps around the nozzle and directs its motion when the sensor and motor are activated. It moves along the body in a consistent linear motion. Finally, we have the dispenser cover. This part snaps onto the body, covering all of the interior components. After looking at the design, there are a few problems that may arise during its use. Since the dispenser is battery-powered, there will always be the issue of the battery reaching the end of its life, and thus stopping the entire function. Additionally, the motor that drives the dispenser could also become hindered during its lifespan and fail to carry out its function. Another problem that arises is that a sensor is used to initialize the process. It could become faulty due to rust, weakened connections, or other issues. And of course, there can be an endless number of faults found within the wiring of the circuitry used inside the product. All of these problems result in the consumer failing to be able to use the dispenser, despite its automated function. The endless complications that are present can be swept away with a very simple adjustment: creating a manual failsafe that coincides with the automated function. Introducing a mechanism that allows the consumer to manually control the dispenser will resolve any potential problems. Here is a design of the manual failsafe. It is a lever that, when pulled, applies force on the nozzle and releases a pre-measured amount of soap. The lever clips into the dispenser lid and can rotate around its axis. The addition of a lever means the lid will also have to be adjusted as well. Now there is a slot for the lever and a space for the lever's axis to rest in. Here is a demonstration of the failsafe in action. When the lever is pulled down, it makes contact with the bottom of the nozzle, and the soap is released from the container. Here is the exploded view of the soap dispenser with its new components. As you can see, the lever fits into the lid from the bottom. The axis of the lever clips into the slots of the lid. Then the lid is attached to the body the same as before. The lever has been designed in a way to avoid interfering with any of the internal components. Even if there are no issues with the automated function, the failsafe can still be implemented without hindering the system. So virtually, there are no downsides to adding the failsafe. This new design only requires 2 new products to be manufactured, and in this slide we will discuss how these 2 components will be produced. The 2 components of the failsafe, both the lever and the new lid, can be manufactured by injection molding. The material to be used will be acrylonitrile butadiene styrene, or ABS plastic. It's a low-cost thermoplastic that has a high strength and very high durability. The reason we are using injection molding is because the new components for the design are simple parts that don't require any special material. Injection molding is a better method than something like casting or forging because it is more suited for the parts needed. Injection molding is a very fast process and can produce large quantities with minimal error. Injection molding also produces very little waste material compared to casting methods. Although it can be expensive to create the mold for injection molding, it is still ideal for mass production and the best option for these 2 components. While the automated soap dispenser is designed well, it is still susceptible to some issues. Adding the failsafe component can resolve any problems regarding issues with the motors, sensors, wiring, and any other electrical components. The new components added to the design are very simple to manufacture and create almost zero interference with the present components in the system. The lever can be used when the parts such as the battery or the motor fail to complete their function. And if everything is working correctly, the failsafe can still remain without any issues. This ensures that the consumer will always have the ability to receive soap out of the soap dispenser, whether it is manually or automatically retrieved. This simple innovation can bring great benefit to the product because it solves all the potential problems of the initial design. Here are the resources used to retrieve any necessary information and references for this project. Thank you for your time.